No, it's great. Thank you. Thank you very much, David. Vincent.
Okay.
We move to employment, unemployment.
All right. So I'm gonna close this workshop with a very dramatic title. But then again, when it comes to unemployment, what is more dramatic than South Africa, right? So the title of the paper is Hopeless Hysteresis, and we're trying to investigate unemployment persistent in the South African series. Well, this talk started. We started as this idea basically came up a while back when we were having a discussion with the guys at the bank about development in the labor market and how it should matter for the Phillips curve when making policy decision. And in this paper, basically, we're just trying to look at we're not trying to see exactly what are the causes of unemployment to begin with, but we're trying to um, investigate a new idea that's just been coming back again, and that is the hysteresis phenomenon, which we believe is present in the unemployment series. Speaking of dramatic, unemployment is basically the defining characteristic of the South African economy, right? Because it went up to 21.1% in the first quarter of 2020, just before the effects of lockdowns could be felt. And then it increased in 2021 quarter two to 34%. And we're talking about the official measure only, because if you include the discouraged and then you talk about the expanded definition, then we increase to a staggering 44%. Now, to put everything into context and to explain to you how dramatic this situation is, just before the crisis, when the South African economy was supposedly doing better, the rate was already at 21%. Now, the young people are particularly affected with a staggering 64% without jobs in the second quarter of 2021. What's interesting about this unemployment series also is that it kind of follow closely GDP growth patterns as shown in the figure. And to better show it, we basically just plot the growth rate and with the inverse of unemployment. And then again, you can see that just post 2008, there seems to be like, you know, a very close movement between the two variables. But then again, this is not really new. In any case, so given these premises, basically what we're trying to do here is trying to investigate what could be the drivers of this double negative trend that we observe in the data. And we achieve this by in two ways. So in first, basically, we're trying to provide evidence based on definition that we find on the literature of hysteresis that could be present in unemployment series for South Africa. And then second, basically, we use a model with insiders, outsiders dynamics to identify what could be the causes of this strong hysteresis that we observe in this series. And then we discuss a little bit what could that mean for policy implications. So let's begin with the first part. Now, the hysteresis phenomenon in economics has been basically pioneered by Blanchard and Sommer in their paper in 1987, when they were trying to investigate the high response of unemployment to shocks, and not just high responses, but also very persistent. And that was back in the 80s. And then the concept basically gained traction recently in the post-2008 financial crisis because of the fact that the economy stagnated for a very long time, despite the fact that monetary policy was very accommodative at a zero lower bound. Now, given that traction, some papers emerged, among which are the two that are reported in this presentation. The first one is by Gali, who basically is an expert in labor market and basically connecting the labor market dynamics with monetary policy development, in which he defines the unemployment, the hysteresis as a long deviation from unemployment with a flexible rate, that is the flexible wage or natural rate of unemployment. And it's a very nice paper where he used a DSU model to basically compare the performance of US unemployment with continental Europe. And you can basically see with the graphs that there's significant differences between the two in the way that the two variables behave. Now, the second paper by Garga and Singh that was basically published this year defined hysteresis not just in unemployment, but also in potential output as a unit root in the underlying basically equilibrium values. Now, when you look at these papers, basically what comes out is the idea that there should be a unit root into the data series, right? And that is easy to prove, and basically the easiest part of the paper by just running DK Fuller test or the Phillips-Perron, basically standard unit root test. And we can find that in the unemployment series, there is unit root evidence in the data. But that only solve one side of the definition, because in a paper by Cross and others, a system that display hysteresis doesn't just have a characteristic of persistence, but also remnants. So basically, the series will have a certain memory of certain shocks. Now, how do you explain this? So this is explained by this graph that we have here, right? So we compare two systems, one where there is a natural rate and another system with hysteresis. Okay, so in the natural rate, in the panel A, where we talk about the natural rate model, so if you have a contractionary shock, the unemployment basically increases from point A, which is the equilibrium one, to point B. And then an expansionary shock will do the opposite. But then as the shock dies out, the system returns to the equilibrium A, okay? Now, in the system with hysteresis, we have a completely different scenario, because when we are equilibrium at A, and then we have a contractionary shock, the rate will increase to point B. But because the system has changed the equilibrium completely, we don't return to point A, but rather to a higher equilibrium to point, which is now A bar. And the same thing basically applied for the expansionary shock, just with the negative sign. Okay, now, remnants is one thing, okay? But what is also very important to highlight is the fact that some series that have hysteresis basically display features of selective memories. So that means some shocks are more important than others. So to investigate that, what we do is basically use a paper by Cross, who applied what he called the Preysack model to the South African unemployment series. Now, the Preysack model is by the author, his name is basically Preysack, who basically uncovered these issues initially in physics. But what it does, the idea of the model is basically to identify what are the dominant shocks in a series by calculating a nonlinear transformation of the initial series, where a certain weight is associated with a certain degree of remnants. Now, in normal terms, without getting too deep into the math of it, just assume a firms that basically acquire new technology with a workforce that is not really trained to use the equipment, right? So obviously, what will happen in the next term is that the workforce a lot of people will leave work. So part of the workforce will decrease, and then when through training and acquirement of skills, you hire more people to a certain level, but that is below the original workforce that you had again. And then with even more training, that workforce will increase again gradually to a higher point than you were in the previous period. Now, what the transformation basically does is that although there has been some development in the workforce in the past, the local dominant level of workforce is what the highest weight will be assigned to. And basically what you had before, in between that local high and the initial shock will be wiped out from the memory bank of the series. But keep in mind that it's still the effect of the original shock that is felt today, okay? And then this will gradually happen until another significant shock happens, and then another weight will be assigned to it, and continuously you will get a new series, okay? So this is basically what we do, and then we assign we use that algorithm, and then we try to test for strong hysteresis using a paper by Prisatelli and others that was published in 2000. Okay, so now when we do that with the unemployment series, we plotted with the unemployment series itself. Then we have the index here in dash, and then the unemployment series in solid. And we're trying to compare how that index does to perform with OECD recession index. And I want to catch your attention just basically to some points. Now we have the 2008. First, let me begin by saying that overall the unemployment, the index seems to catch very well all those crises that happened in the past. So in 2008, when the financial crisis occurred, we basically had no significant impact on the unemployment series. But we argue that this is basically because the Treasury had fiscal space, and they could limit the effect of the shock. But then again, when that fiscal space started to disappear around just after 2009, we catch that sharp increase into unemployment, right? And then nothing significant happened, no big shock happens. And then the unemployment rate basically just plateaued to that level, okay? And then in 2015, we have this political turmoil that was occurring in South Africa with the firing of Nene, and then the downgrading to junk status. Then we have again this peak in unemployment, right? This was basically also captured by the index that Cyril was discussing on yesterday when he was talking in his paper. And the unemployment started going up again until it reaches a certain plateau. And then we're talking about the 2019 crisis again, when South Africa was suffering from a significant recession, and then the unemployment goes again. And we don't want to include the COVID situation, but we're pretty sure that the situation can be captured in this same paper. Now, how we test secondly for strong hysteresis by basically running an out of sample forecast of the unemployment series, right? First, we do an AR1 process, and what it does is just basically just a straight line, saying that the unemployment yesterday is going to be the unemployment today, basically. And the solid line is actually the series, okay? Now, when we use the index itself with the unemployment series as control variables, then we can see that it does very well into basically predicting the unemployment in the unemployment rate. So we conclude that this could be something that could be present in the unemployment series, okay? Now, given this finding, what we do now is basically assessing what could be the causes and the consequences of this finding on the unemployment series in terms of policy implications. So to do that, we use a simple model following a formalism by Blanchard and Qua that was published in '89, and we augmented with insiders and outsider dynamics to account for hysteresis. Now, the model also accounts for imperfect competition in product and labor market to take into account the monopolistic structure, and firms produce the same good and then use the same technology, and the wages are uniform. So the model is basically given by this set of equation in log terms. You have the production function, which is basically a typical Cobb-Douglas function without capital. And then you have demand for goods that is basically impacted by demand shocks. And then you have the prices that is basically a function of markup on unit prices. Then the labor market that is defined by two equations, so that the labor force is given by the unemployed and the employed, and then a version of it where it depends on the real wage. So we have a couple of disturbances that are random walks and that are typically shocks to productivity, that is AT, and then demand shock, and then you have the markup shock, and here we have a labor-related shock. Now, we're talking about, we bring in the insider and outsider dynamics, and we explain the hysteresis assumption, okay? So each year we have wages defined to meet a certain target, which is defined by WT star. But then again, the deviation from this target can be impacted by shocks of wages, demand, and prices, okay? Now, how is that target defined? The wage depends, the targeted wage basically depends on what will be the level of employment in the future, okay? And the expected employment itself depends on the level of the labor market, the labor participation, and then the employment in the previous periods. and it's a very important coefficient that we call lambda. Lambda is comprised between 0 and 1, and it denotes the hysteresis parameter. Okay, so now this is where also the bargaining power of unions comes into play. Okay, so you have two versions. You have the insiders and the outsiders. The insiders are the employed, and then the outsiders are basically outside of the labor force. So if you have a coefficient that is set of lambda, that is set between 0 and 1, okay, then the bargaining power of the workers, it's set into taking into account the unemployed, okay, people who are outside of the market. In that way, we will have an expected level of employment that will be higher than the previous period, right? Simply because of the coefficient. However, if you assume full hysteresis, right, in the economy, then this coefficient goes away, and then basically we have the expected level of inflation that will pretty much be the same as the one in the previous period, therefore keeping the unemployment rate very high. So this is important because when the hysteresis basically coefficient basically give higher weight to the insiders compared to the outsiders. Now, to solve this model, what we do is basically assume a full hysteresis because of the evidence that we find in the first part of the paper. And once we do that, we can express the system into moving average as the following set of equations. And we estimate the model using Bayesian VAR techniques. And what we will only report shocks that are of interest to us, because anything else is in the paper, and then it's in line with previous literature. And here, what we focus on is basically the nominal wage. Okay, now the nominal wage shock will increase prices, okay, and then raise unemployment with no significant effect on output and employment per se. So the impact on prices seems to be long lasting, while the unemployment effect is very low. Next, we move into the markup shock. Okay, an increase in prices basically reduce the unemployment rate with no significant impact on output and nominal wages. However, we have a strong and quasi persistent response of unemployment, okay, which is a significant feature of hysteresis. So basically what we observe here is that there seems to be a very strong connection between the nominal wage, the prices, and the unemployment rate. And this is basically confirmed also by the forecast error of variance decomposition. Now, nominal wage as the horizon expand is basically mostly explained by its past value and some demand shock. Now, when you look at prices, the impact, the contribution of nominal wage shock in explaining prices variance decomposition errors is gaining as time goes back. There's also a significant, an important impact of a supply shock. Now, this contributes to also an increase in unemployment because price markup shocks are significant into explaining unemployment. So the main takeaway from this is basically that all these factors seem to be interconnected, and it's very important to take into account labor market developments into into the specification of the Phillips curve, especially into defining the wage Phillips curve itself. So this is basically what I had in mind today, and I would like to conclude by saying that all these linkages are very important for policy implications, but also what is very important from the index that we created using the algorithm in CROSS or the PRESAC model is that unless things get better, or unless something good happens or something positive happens in the economy, the unemployment rate seems to just keep rising and rising. And this is very important because now we are in a state where the COVID pandemic is still being felt, as we can all see, and well, hence the hopelessness of the scenario. Thank you for your attention.
Thank you very much. Thank you, Vincent. Questions? Gideon, go ahead.
Given that you are a co-author on this paper, Nicola, I decided to go first.
Thank you. I didn't want to ask myself question. I already look all day to myself in this Zoom thing.
I think this is exceptionally important. I think hysteresis is one of the most undervalued parts of what macroeconomists have missed. So when there is a stochastic trend in any series, it will dominate anything that we study as business cycle economists. So in this sense, I think this is an important study. I have not really questions, but 2 comments. The one thing is you use a model without capital, and I understand the simplifications, why that's necessary, but in the South African context, to me, it feels critical that part of our problem is we're becoming more capital intensive. And that is another source of hysteresis in the labor market, because it's easier to allow unemployment to rise when the rest of the economy can substitute with capital. And that, to me, feels like what's happening. That's one minor point. And then a technical one. I'm an econometrician as well. I've never tried to publish much econometrics, so you can dismiss my opinions. But when I see on a impulse response function, and when I see what's called the confidence bands diverge at the end of what you present, I become worried about statistical stability of the process. So almost always, if you extend it long enough, they will eventually converge again. But just something to show on what horizon do these confidence bands converge. That's something about the precision of the estimation, which in a setting like this, one does not expect much. So I'm happy. And so these are 2 technical comments that you don't actually have to comment on, just for later, perhaps.
Okay, well, thanks for those points. It's funny that you say capital, because every time we have this conversation with Prof. Nicola, is always the same thing that we say, that we totally agree with you that there's as soon as there's a shock in the economy, the firms basically switches to capital. That is a given, right? But again, this is just what we will call like a big look at the data, right? We intend to dig deeper into that and then take into account capital, that's for sure. And as for the second comment, yeah, I totally agree with that too. Hence, that's why I said, I use the word, I guess, quasi-permanent, because I didn't want to just push it a little bit too far. But then again, if you argue that we're talking about quarterly data, and then if it takes about 20 quarters to converge, then I guess it's a very long time, don't you think?
In order to,
I agree. And I think just for...
Plus, there is an heroic thing that we do, that is using unemployment data that we have.
That's true.
Therefore, there is an element of
Absolutely.
the quality of the data when we try to work on this area, but in some sense that generate these econometric problem, for sure.
It's very difficult. No, I agree. I was just pointing out 2 things.
No, it was great.
That I saw.
Thank you very much
Christian.
for the
Christian, go ahead.
Yes, thank you very much, Prof. Thank you.
How are you, Christian?
I'm doing good, Prof. How are you?
I'm fine. Nice to hear from you.
Yeah, nice to see you, Prof. Vincent, thank you very much for the presentation. Unfortunately, you on your equations, you really speed up, so I couldn't really remember all the equations you had, and especially your estimation. I don't know what was the length of your variables you look at, but as we're talking about unemployment, I'm 100% sure you've covered the period during COVID, probably. The 2007 financial crisis.
We don't cover COVID.
You didn't cover COVID?
No, we stopped right in 2019.
So before 2007 financial crisis?
We start from 2000. We include the financial crisis, but
yeah. So basically, you have the 2007 financial crisis, and I'm wondering if but if you should not take into account the nonlinearities by looking at some nonlinearity modeling strategy, like a regime switching, probably will help here. Yeah. And two, I want to know that I can see your model is linear, so you linearize it by hand probably. That so you estimated the first order DSGE?
No, it's a VAR.
Oh, it's a VAR. Okay, perfect. So yeah, if you can look at regime switching, I'm sure you can learn more.
Okay.
Okay, and with the impulse response function, the band, I know it's quite a mission to have them behave the way we want them to behave. It's usually challenging, so I understand what you went through. So yes, it's not, for me, it's not really a big issue. So probably it covers also the uncertainty, as you say, as we move to 20 quarters. We really don't know what will happen during those periods. Okay, but thank you for the presentation. I really enjoyed it, Vincent.
Thank you for your comment, Christian.
Okay, thank you, Prof.
Thank you, Christian. I hope to see you soon.